my today's session. This is a special session and it is on definition and terminology, some important definition and terminology on force on electromagnetic field. Myself, Dr. Sayanti Chatterjee, Associate Professor of Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. So the main outcome of this topic is predict the force due to the moving charge in the magnetic field of various configuration for developing principles of electrical machines. That's why it is very important. First question, explain the force on the moving charge. Force on the moving charge is equal to, we know, F equals to Q V cross B. So according to the definition and terminology, we can only write F equals to Q into V cross B. But what is behind this? Magnetic fields can exert a force on electric charge only if it is moving. Just a moving charge produces a magnetic field. If the charge is not moving, it will not experience any force. The force increases with both an increase in charge and field density. From this equation, you can see if the charge is increased, and magnetic field intensity B is increased, the force will increase. The force is greater when the charges have the higher velocity. If we know the flow of current means the rate of change of charge. So if the charge has the higher velocity V, the force will be maximum. So we can also tell that magnetic force always works perpendicular to the velocity. That's why we are using the equation V cross B, where Q is the charge, P is the velocity, and B is the magnetic field. It acts out of the plane and does not contribute any work done on which. As this is a cross product, we can also write F is equal to Q. We can also write QVB sine theta. So we can understand that the magnetic force depends on the angle theta. It always acts out of plane and does not contribute to any work done. It can merely change the direction of velocity but cannot change the magnitude. And it always follows the Fleming's right-hand rule. What is the Fleming's right-hand rule? Fleming's right-hand rule means if we keep the three fingers perpendicular to each other, if the first finger tells about the magnetic field, if the middle finger tells about the direction of the current, or we can tell the charge, it will be gives the V, the velocity. So the velocity value cannot change the direction. It depends on V and B, but it will not change the magnitude. Next important question. Explain Lorentz force. Lorentz force is the application of the electromagnetic field, the force in electromagnetic field. So already we know if there is a charge, think about the DC motor. So if there is a north pole and south pole, one magnetic field, and if we keep some current carrying conductor in it, if we keep any current carrying conductor in it, what will happen? That it will feel two type of force. One is electrical force, one is magnetic force. The electrical force is AP is equal to Q, charge, and E, where E is the field intensity. Electric field intensity actually. And if we write the Fm, as this is the magnetic field also, Fm is equal to Q is equal to V cross B. So what is the total force? Total force is equal to Fe plus Fm. Fe is equal to QE, Fm is equal to QV cross B. So what is the total force? If we take Q, E plus V cross B, and this is known as the Lorentz force. This equation is basically known as the Lorentz force. So whenever there is a charge in an electrical field, whenever there is some charged particle in a magnetic field, it will experience two types of force. First one is the electrical force and second one is the magnetic force. So their total force is equal to electrical force plus mechanical force, and this is known as the Lorentz force. So we move to our question number 3. Write the limitations of the moving charge in magnetic field. What are the limitations? So if the velocity of charge in the magnetic field is 0, the force experienced is 0. So if we write F, first we will write the main equation. F equals to Q into E plus Q V cross B. Now, if the velocity of the charge in the magnetic field is 0, then the force experienced is 0. If we think about only the magnetic field, so what is the equation of the magnetic field? Q equal Fm is equal to Q V cross B. So, if the velocity is 0, the force will be 0. What is the meaning of velocity equals to 0? Velocity equals to 0 means whenever it is a current carrying conductor but it is not rotating, it is a fixed one, then we can say the force will be 0. If the velocity direction and magnetic field direction are parallel to each other, force experience to 0. So what does it mean? V cross B means B sin theta. If B and B both are parallel, means the angle between B and B, theta is equal to 0 degree. So theta is sin 0 is equal to 0 and the force will be 0. That's why if the velocity direction and magnetic field direction are parallel to each other, if the angle between them is 0, then the force will be 0. To say that moving charge in a magnetic field experiences force velocity must be normal to each other. When V and B both are normal to each other, then angle is equal to theta equals to 90 degree, then force should be maximum. Otherwise, force cannot be the maximum value. So these three are the main limitations of the moving charge in the magnetic field. Next important topic is the deduce the force on the current element due to magnetic field. So let's think there is a current carrying conductor in a magnetic field and it is taking the current I. We have to calculate the force on the current element due to magnetic field. We can prove this into the two methods. First is method 1. Say we are thinking about a small length L. We are just assuming a small length L and the L length is dl. The value of this length we are assuming this is as dl. So what is the current in the small length? The small length current is given as the IDL. So already we have discussed that the force in a magnetic field is equal to dF is equal to dQ V cross B. And what is V? V is equal to velocity is equal to dl by dt. Velocity means rate of change of the distance. So we can write V is equal to dl by dt. Again, what is dq? dq is equal to rho v into dv. Here small v is the volume. What is rho v? Rho v is equal to volume charge density is equal to dq by dv. So what is df? Df is equal to dq dl by dtb, or we can write, if we change the rho v, dv, v cross b. So what is rho v into v? According to the rule we have discussed in the second unit, the J, current density. What is J? J equals to current density. J is equal to current density. What is the meaning of current density? Current per unit cross-sectional area. So the relation between J and velocity V is equal to J equals to rho V into V. So if J is equal to di by ds, we can write J into dv is equal to I into dl. How we can write? We know J into dv. What we can write it? dv means volume. Volume means length into surface area. What is the meaning of volume? The length into the surface area. So J into S into dl. And what is J into ds? Current density into surface is equal to total current into dl. So we can write I dl. So I cross B is equal to F equals to BIL sin theta. Actually it will come IB dl sin theta, and if we integrate both sides we will get F is equal to BIL sin theta. This is the method 1. So another method is there. The method 2 is also there. I will write from here. So we got df is equal to dq dl by dt into b, or we can write it like this: dq by dt dl cross into b. What is the meaning of dq by dt? Rate of change of charge is equal to current I dl b sin theta. So we can write it also. If we take the integration both side, I b l sin theta or b I l sin theta. So method 1 and method 2, we can prove this rule in the both sides. Next important question. Write the expression for force due to parallel straight conductor. So let us consider two straight parallel conductors carrying current of I, and they are separated by a distance d. So the magnetic field intensity H is equal to I by 2 pi d according to the Ampere circuital law. Or we can also prove this, that we know H is equal to number of turns N into I, number of turns per meter into current, or we can write I1, N by L into I1. What is N? N is equal to total number of turns. N is equal to total number of turns is equal to small n cap L. So what is L? L is equal to, it is a circular path, so L is equal to 2 pi d. So what is B? Relation between B and H is B is equal to mu naught H. So if we put the value of H here, we can get B is equal to mu naught I1 by 2 pi d. So what is F1? F1 means force on the second conductor due to the first conductor. So what is this? B I2 into L. So what is the value of B? B value is mu naught I1 by 2 pi d I2 into L. So if we put the value, we will get mu is equal to mu naught I1 I2 L by 2 pi d. we will get the same force using the second case also. We will get the same force using the second case also. So F1 is equal to F2, both equals to mu I1 I2 L by 2 pi d. And if we want to calculate the force per unit length, mu naught I1 I2 by 2 pi d. Next, classify the magnetic potential. What is the meaning of magnetic potential? Magnetic potential is the property or substances or phenomena that gives rise to the magnetic field. Magnetic potential is basically two types. One is the scalar potential, another one is the vector potential. What is scalar magnetic potential? Scalar magnetic potential written by psi is a quantity in classical electromagnetism which is analogous to electrical potential. So what is the meaning? The work done to bring one unit north pole in a magnetic field is known as the magnetic potential. So we can write E is equal to minus grad into V. Similarly, we can write, this is for the electrostatics. If we want to write for the electromagnetics, it is given that AH is equal to minus grad Vm. What is Vm? Vm is the vector magnetic potential. The Vm is the magnetic potential. Again, if we take the grad in both grad cross both side, what will happen? Grad cross grad Vm equals to 0. So grad cross H is equal to 0. What is the divergence of curl of a vector? The divergence of curl of any vector is 0. This is a very, very important thing. If one vector is A, if we take the curl means grad cross A, and if we take the divergence means grad cross A equals to 0. We can prove this. Say A equals to x square plus y square. Just we are taking one simple example. X square ax plus y square ay. So what will be the value of grad cross A? So we will write what is the meaning of grad? Grad means del by del x plus del by del y, plus del by del z is also there, but as we are taking it is a two-dimensional, we are writing del by del x in plus del by del y. So what is the meaning of grad cross A? How to do this? Ax ay, del by del x, del by del y, x square ax plus y square ay. So what will be the value? Okay, for this is coming 0 here. So if we also write y x square plus y square x. So what is the value? Grad ax. So x ax plus minus y ay. Now if we want to take the divergence of this one, I am writing this as P. So what is the meaning of the divergence? Divergence means del by del x plus del by del y. If we calculate it, we can get, actually if we take it, it is coming y square. So if we take the we can take ax, but del y by del x is always 0, and this is constant with respect to x, and this is constant with respect to x. So the result is 0. So the simple answer is the divergence of curl of any vector is always 0. Next, what is scalar magnetic potential? Scalar magnetic potential, already we know E dot dl into V. We got it in the case of the electrical potential. So similar thing, if we write in the magnetic field, we can get H dot dl is equal to Vm. What is H? H is nothing but the magnetic field intensity. So if we take the integration both sides, we will get, as from the Ampere circuital law, H dot dl is equal to I from the Ampere circuital law. And if we equate these two lines, we will get the scalar magnetic potential equals to I, and its unit is ampere. This is a very important thing. The unit of the magnetic potential is ampere, not volt. What is vector magnetic potential? So vector magnetic potential is also a classical vector quantity in classical electromagnetism, where it will always follow the rules grad cross A equals to B, and this A is known as the A is known as the magnetic vector potential. We also know the divergence of the magnetic field intensity is always 0. So grad B equals to 0. So if we put here grad cross A is equal to also 0. And also we know that the previously we have discussed the previous question, the curl of a divergence of a curl product is 0. So this is the special case of the vector magnetic potential. Write the NEUMAN formula. NEUMAN formula is very important in case of the mutual inductance. So what is NEUMAN formula? We are assuming two current carrying loop are there who are change in a distance of r. Their distance between them is r. In one side current I1 is flowing, in another side the current I2 is flowing. We are assuming that it has the S1 and its cross-sectional area is S2. So already we know what is B1. B1 is equal to grad cross A1. The vector potential of this is grad cross A1. We have just discussed in the previous slide that grad cross A equals to B. We are using the same formula. B1 is equal to grad cross A1. And what is A1? A1 is equal to integration of mu I1 dl1 by 4 pi r. This is the potential value. So what is the flux linkage phi to 1? What is the meaning of phi to 1? Flux linkage in the second coil due to the first coil. So we can write B1, the flux linkage due to the first coil, ds2 in the second coil. And similarly psi to 1. So what is the total value? Psi to 1 means the total flux is the integration of B1 ds2. So we can write in the place of B1 grad cross A1 ds2. The same thing we can prove for the psi to 1 also. What is the meaning of psi to 1? The total flux of the second coil due to first coil. So what is the inductance? Inductance is equal to psi to 1 divided by I1, and this is known as the NEUMAN formula. This equation is known as the NEUMAN formula. Give the expression for self-inductance of the solenoid. So what is solenoid? Solenoid is nothing but a bar on which we can keep the electrical coils. So if the total number of turns is, if the length is L, if the total length is L and N is the number of turns and capital N is the total turn, we can write capital N is equal to N into L. So the magnetic field intensity in the solenoid is B equals to mu not I, because A is equals to Ni and B is equal to mu naught into H. So what is psi? What is the flux? Flux is equal to N, number of turns, total number of turns, B into A. So if we put the value, we will get mu naught N square Ia into L. So what is inductance? Inductance is equal to mu naught N square IL divided by I or divided by L. We can write it as a inductance of the coil. Give the expression for the magnetic flux in N turns if B and A are known. So this is again the expression from the previous one. Let us consider a solenoid as shown in figure with length L allowing to a current of I ampere. N equals to number of turn and capital N is equal to total turn. And if the length of the solenoid is taken as L, if the total length of this solenoid is taken as L, we can take N into L. So what is the magnetic flux inside the solenoid? Already we have discussed. B equals to mu naught N into I. What is N? Again, if we put the value of N, we can write mu naught capital N by L into I. So if B and A are known, so phi is equal to N B into A, where N we know, B is equal to mu naught N I by L, and if the length is L and the width is B, cross-sectional area is equal to L into B. L into B. Next, define the magnetic dipole. It is similar to the electric dipole. If we bring two charges nearer to each other, it will feel some force. So what is magnetic dipole? Magnetic dipole is formed when two opposite magnetic charges are separated by a distance of 1 into, or we can tell it as the L meter, distance by a L meter. If the L is, and one important thing is, like the electric dipole, two opposite magnetic charge, both magnitude should be same, but both direction will be opposite. So magnetic dipole is formed when two opposite magnetic charge are separated by a distance of 1 meter or L meter. The line of joining in term of axis of the dipole, this is known as the axis of the dipole. Which one? The line of joining of the two charges, this is known as the axis of dipole. The direction of magnetic dipole is from minus qm to plus qm. The direction is from minus qm to the plus qm. And in the other words, if a bar magnet with pole strength qm and L has and the distance is L. The magnetic dipole is QM into L. Say we are thinking about a magnetic bar. Sorry. And it is QM. The distance between them is L. One is plus, another one is minus. As we have discussed that there is if we do not take care of the direction, we can tell the magnetic dipole M is equal to QM into L. So QM is the value of the magnetic charge. Write the expression for magnetic dipole moment. We will discuss about the expression for the magnetic dipole moment. So, same thing already we have discussed, that if we are taking one bar magnet, this is a bar magnet, one charge is plus QM, another charge is minus QM, and they are at a distance of d meter, L meter, and so due to this charge it will feel some dipole moment. And what is the value of the dipole moment? The dipole moment value is the M equals to QM into I. Now, let us consider a bar conductor allowing a current I in they are forming the loop of cross-sectional area A. If this is a path, there is a cross-sectional area A. So, magnetic dipole moment M is equal to I into A ampere. So, what is the dipole moment? If the current I is flowing in this loop, what will happen? It will also create some dipole moment, and the value is M equals to I into L. So, we can write QM into L is equal to I into A. So, this is the relation between the electric dipole and magnetic dipole. QM into L is equal to I into A. Define magnetization. If there exists a conductor consisting of number of dipoles in its volume, then the magnetic dipole moment per unit volume is called as the moment per unit volume is called as the magnetization. So, what is this? M by V. M is the magnetic moment, V is volume. So, already we have discussed what is M. QM into L. What is, I have discussed in the previous slide, magnetic moment is equal to QM into L. What is the volume? If the cross-sectional area is A and length is L, so volume is equal to A into L. So, magnetization M is equal to QM by A. Magnetization M is equal to QM by A. And this is the last question. Write the expression for the torque due to a moving charge. So, the expression for the moving charge, the expression for torque due to a moving charge. So, if this is a north pole and this is a south pole, and if we keep one current carrying conductor, moving charge means current. So, whenever there is a moving charge, there should be a current. So, it will feel some force. And when the force is in the rotational direction, we can call it as the torque. And we can tell the moving charge, the expression of the torque is T into B. It is T into B. So, what is torque? Torque is 2 into torque on each side. When there is a current carrying conductor, what will happen? It will feel one force this side, another force this side. It will feel two types of force. One torque is this side, another torque is this side. So, as a result, it will start to rotate. So, 2 into torque on each side. So, what is torque? Torque means force into distance. So, 2 into force into distance from axis of rotation. If this is the axis of the rotation and it is d by d, total length is d, we can write 2 into f into d by 2, and this value is equals to the BIA cos beta. So this is the expression of the torque is equal to T is equal to B, the flux density, I, current, A cos beta is equal to the length. So this is the expression of the torque in a moving coil. Write the characteristics of permanent magnet. Permanent magnets are the one which readily available in the nature in the form of bar or horseshoe, etc. Permanent magnet, irrespective of supply, always exhibits the magnetic property. For the permanent magnet, no need to give any power or any current. It will automatically, it is a natural thing, and it will automatically show the magnetic property. Permanent magnet always develops a constant magnetic field. As the field strength is always constant, it is always showing the constant magnetic field. So these three are the basic property or basic characteristics of the permanent magnet. Again, the strength of permanent magnets measured in terms of the cohesive force, the amount of force at which it will attract something. And a permanent magnet with high cohesive force has the long life. Permanent magnet got the disadvantage of aging effect. If we use a permanent magnet for a long time, for a long run, due to corrosion and any environmental condition, it will just got rusted and it will lose its power. So what are the application? Permanent magnets are used in the application over it is required to develop the constant magnetic field. The example is PMDC, permanent magnet DC. It is basically two types we get in the our environment or in nature. One is the butt type, where North Pole and South Pole. Otherwise, we get the like a horseshoe, where we get the North Pole and South Pole. The magnetic force is more in case of the horseshoe than the bar permanent magnet. So this is the today's topic, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.